Hi everyone, welcome to my channel. Today I'm going to show you how to set up a high availability cluster using Pacemaker, Corosync, and DRBD. High availability clusters are crucial for ensuring that your services remain up and running even if one of your nodes fails. What is high availability cluster? A high availability cluster is a group of computers that work together to ensure that critical applications can be reliably provided to end users. They are essential for minimizing downtime and ensuring continuous service availability, which is critical for businesses that need to maintain high levels of uptime. In this setup, we'll be using three main tools: Pacemaker, Corosync, and DRBD. Pacemaker is the cluster resource manager. Corosync is responsible for the messaging layer. DRBD is used for data replication between the nodes. Here's a diagram of our HA cluster setup. As you can see, we have two nodes, Node 1 and Node 2, each with multiple network interfaces for different purposes. We also have a virtual IP that the user PC connects to. This IP will float between the two nodes in case of a failover. Nodes. These are the physical or virtual servers running our services. Network interfaces. We have three interfaces on each node for different networks: Corosync, DRBD, and user connections. Virtual IP. This IP will be used by clients to connect to the services. It can move between nodes to ensure continuous availability. For this test, I'm using Hyper-V Manager to set up virtual machines for Node 1, Node 2, and the client. I've already created the virtual machines and installed the operating systems. Node 1 and Node 2 are running Ubuntu server, while the client is running Windows. For Node 1 and Node 2, create three network interfaces. The first network interface is for Corosync, the second is for DRBD, and the third is for redundancy. I'm going to use the Windows command prompt to connect to Node 1 and Node 2 via SSH. Now that we have connected, the first step is to edit the host file on both Node 1 and Node 2. Type in the IP addresses that we set up earlier. This ensures proper name resolution between the nodes and the virtual IP. Now to test the connection, try pinging the IP addresses. Next, update Ubuntu and install DRBD and resource agents on both nodes. This updates the package list and installs the necessary DRBD utilities and resource agents. No configuration is needed for postfix since I do not require a mail server in my setup. Once the updates and installations are complete, create a logical volume. Before doing so, list the disk partitions to review the available partitions. It appears that /dev/SDA3 has a total size of 48 gigabytes, and the volume group and logical volume have already been created. However, only 24 gigabytes of this space is currently in use. Let's check how much free space is left. The allocation shows that approximately 24 gigabytes has been allocated, and the remaining space is free. Let's create a logical volume from the free space. I only need 1 gigabyte for this new logical volume, which will be named Tech Priority. Do this on both Node 1 and Node 2. Once Node 2 is done, it's time to clean up the disk, logical volume, on both Node 1 and Node 2. This command writes zeros to the logical volume to clean it up. It may take some time depending on the size of the disk. Next, we need to disable DRBD on startup on both Node 1 and Node 2, since Pacemaker will handle the job for DRBD. Now we can start editing the DRBD configuration file. Begin by configuring global common.config. All of the lines in this configuration are already created by default. I only need to type in 2 lines, so I need to delete all the lines in this configuration file. I'm going to use Vim to delete all the lines. Vim is another editing tool besides Nano. To delete all the lines in the configuration file using Vim, type %d. Take note, you have to press the escape button to enter command mode and make changes to the configuration file. Now you can edit the file. To save the configuration file, enter command mode by pressing escape, then type WQ. This will save the file and quit Vim. Next, it's time to create a resource file named r0.res and edit it. This configures the DRBD resource, R0, on both nodes with the logical volume and network settings. Do this on node 2 as well. Once done, we can start replicating the disk. First, load the DRBD kernel module. Do this on both node 1 and node 2. Create metadata for the DRBD resource on both node 1 and node 2. Now bring up the DRBD resource on both node 1 and node 2. Now, we need to establish and update the mirror. Perform this only on node 1. Since the data disk is empty, use the command sudo drbd adm new current UUID clear bitmap r0/0. This command will set up the DRBD resource and clear the bitmap, but no data replication will occur at this stage. Next, we need to make one of the nodes primary. I'll set node 1 as the primary. With the DRBD setup complete, you can check the DRBD status using the following command. Verify that the connection has been successfully established. Now we need to format the DRBD device. Do this only on node 1 since we set it up as the primary earlier. Finally, I want to save the DRBD device in /var/www/html, so we need to create the directory first. Use this command which will create the directory if it doesn't already exist. Do this on both node 1 and node 2. Now it's time to set up Pacemaker and Corosync. First, we need to install them on both nodes, along with CRMSH and Samba. CRMSH is a cluster resource management shell used to manage resources, and Samba is for file sharing. Once the installation is complete, enable Pacemaker and Corosync. Now, configure the Corosync file on both nodes. I'm going to name my cluster HA cluster, SEC auth. This parameter controls whether security authentication is enabled for Corosync's communication. When set to off, security authentication is disabled, allowing communication between cluster nodes without verifying their identities. This simplifies configuration but lowers security. Since this is only a test, I've set SEC auth to off. This makes setup easier but reduces security, which could be a concern in a production environment. Net. This transport layer is designed for efficient and high-performance network communication within a cluster. I'm setting RRP mode to passive for this small setup. The available modes are active, passive, and none. Passive mode is suitable here due to the small scale of the setup. For network addresses, I'm using two ring addresses, 192.168.1.0 for Corosync and 172.16.1.0 for redundancy and client network. Two-node 1. This setting configures quorum behavior for two-node clusters. When set to 1, it enables special handling for quorum in a two-node setup, ensuring the cluster continues to function even if one node fails. Wait for all 1. This setting controls whether Pacemaker waits for all nodes to be present before taking action. When set to 1, Pacemaker waits for all nodes to join the cluster before performing operations, preventing split-brain scenarios and ensuring consistency. Last man standing 1. This setting determines the cluster's behavior when only one node remains. When set to 1, the remaining node is allowed to keep running and manage resources, ensuring the cluster stays functional even with just one node. Auto tiebreaker 0. This setting relates to handling tie situations and quorum votes. When set to 0, the automatic tiebreaker mechanism is disabled, which is useful if you have a manual tie-breaking mechanism or need to handle quorum decisions manually. Next, we need to edit the Samba configuration file on both nodes. We'll be adding or modifying share definitions to meet our requirements. For this setup, we'll point the share to /var/www/html, where the DRBD device is mounted. Time to set file or directory permissions for the shared file. Chmod 777 gives everyone full read, write, and execute permissions on a file or directory. This is risky because it allows any user to modify or delete the file. Since this is just a test, there's no need to worry. Finally, enable and start Samba. Also, start Pacemaker and Corosync. No need to enable Pacemaker and Corosync since we already did that. That wraps up part 1 of our high availability cluster setup tutorial. Here's a quick recap of what we've accomplished. Installed and configured DRBD, including creating and managing logical volumes. Set up Samba for file sharing and adjusted permissions. Configured the Corosync configuration file to prepare for clustering. In part 2, we'll dive deeper into configuring the cluster resources with Pacemaker and Corosync to ensure everything is working seamlessly for high availability. If you found this video helpful, make sure to hit that like button and subscribe so you don't miss part 2. Feel free to leave any questions or comments below, and I'll see you in the next video.